And I'd like to welcome you again to our webinar today. And our topic is about how to write your research proposal for our Doctor of Engineering course. And this is an information session webinar only. So this will be led by Dr. Vishal Sharma and Dr. Arti Sidupra. So this is not a technical webinar, but rather an information session webinar. Okay. So I'd like to also remind everyone that we will be giving out a copy of the slides and a video recording as well, and it will be sent to you within the next 2 business days via email. So please monitor your inbox and your junk folder as well. And before we start anything about the research proposal topic, I would like to give you some tidbits of information about EIT. So we would like to also highlight that we are dedicated that our students would receive a world-class education and gain skills that they can immediately implement in the workforce. And we are also an engineering specialist type of institute, and we are one of the only institutes in the world specializing in engineering. And we deliver a variety of courses from professional certificates, diplomas, advanced diplomas, undergraduate and graduate diplomas or certificates, and also our higher education courses, which are the bachelor's and master's degree and a doctorate of engineering. We also have industry-oriented programs. So these programs are designed by industry experts, just like our speakers for today, Dr. Arti and Dr. Vishal as well. And this is to ensure that when you graduate from EIT, you will have cutting edge skills that are valued by employers, and these program contents also remain current with the rapidly changing technology and industry developments. And when it comes to accreditation, we have Australian accreditation as well as world-class accreditation. So we have vocational programs. We also have higher education degrees that are registered and accredited by the Australian government. And we also have some programs that are also recognized under the 3 international engineering accords by Engineers Australia. And these are the Washington, Sydney, and Dublin Accords. And of course, we have industry experienced lecturers, and they are highly experienced engineers and subject specialists with applied knowledge. And of course, the technologies employed by our school or institute for both online and on-campus courses enable us to source our lecturers from a large global pool of expertise. We are also proud of our unique delivery model because we deliver our programs via a unique delivery methodology that makes us use of live and interactive webinars like this for our lectures and classes. And of course, our international pool of lecturers, as mentioned earlier. And we also have our dedicated learning support officers. This is something unique to EIT as well. So aside from your lecturers, we have people that you can go to whenever you have challenges regarding your studies, and they can guide you all throughout, helping you succeed in your studies at EIT. We also have state-of-the-art type of technology when it comes to learning technology. So we have workshops. We can accommodate that even in an online learning setup. We also have remote laboratories and simulation software so that you can have as close as possible to the real world experience while studying. And that's it about EIT. I hope that it can help you when you decide to choose EIT or when you decide to study a course. These information can help you. And our first presenter for today would be Dr. Vishal, and he will be telling us more about himself. Dr. Vishal, feel free to go ahead and take over and start your lecture. Uh, Hello?
Sorry, Lisa. I think the first part is for me, so maybe I can introduce Vishal.
Okay. Okay. Yeah, you can. Do you want to? All right. Go ahead.
All right. Eh, Hello and welcome everyone to this D.Eng research proposal webinar. Myself and Vishal, we will be presenting this webinar jointly. So I will be doing the first part, and second part, Dr. Vishal will take over. Now, first, let me introduce ourselves, and then I can start talking more about the initial parts of your research proposal. So Dr. Vishal Sharma, he is a D.Eng coordinator here at EIT. So he takes care of overall the D.Eng program, the research aspects, as well as the academic aspects of the D.Eng program. He is an esteemed senior on-campus lecturer, and he specializes in mechanical engineering. He has more than 25 years of experience in teaching as well as research, and he has also made some significant contributions to the field of advanced manufacturing. Now, his research in advanced manufacturing has led to quite a lot of reputable publications with quite a lot of citations, earning him a notable H index of 34 on Scopus. He has also demonstrated leadership by organizing 7 international conferences, editing special journal issues, and publishing 3 books with very reputable Springer publishers. Vishal has also successfully supervised quite a few PhD and master students, and that's how he's fostering their academic growth while serving as an associate editor for prestigious journals in the field. So that's about Vishal. And moving on, I will take this opportunity to just briefly introduce myself as well. So my name is Aarti, and I am an academic. I have been in academia for more than 18 years now. I have been with EIT for the last 5 or 6 years. My research interests, they align really well with what Vishal has proposed, manufacturing and smart manufacturing. Again, that's my field of expertise, mechanical engineering. And yes, I am looking after Bachelor of Mechanical Engineering program here at EIT. I'm also looking after graduate certificate in safety, risk, and reliability, as well as I'm also deputy coordinator of this D.Eng program. So that's about me. All right, I'm moving on and looking at the agenda, what we will be covering today. So let me just change the color to something else so that we can see. All right, so the first part is identifying the research problem, because that formulates the main part or the body of your research proposal. That's how everything starts. And then secondly, we will consider literature review process. So how the literature review is carried out and why it's important and what it should include. So that would be there. These two topics I will take care of, and then I will give back to Vishal. So Vishal will focus on steps for research design and methodology. He will also talk about research timeline and budget and how you can include that in the research proposal. And he will also cover the examples of research topics. All right, so with that, let's get started. All right, so first of all, I would like to clarify there is a huge difference between PhD and D.Eng, and I want everyone to understand that difference. So if we consider PhD, objective-wise, PhD main objective is to advance theoretical knowledge and understand a very specific field. So PhD is more theoretical based, while D.Eng, if you consider, the main objective here is to apply that advanced research and technical skills to solve complex industry problems. So D.Eng is more application based. Focus-wise, PhD would focus on original research, which would contribute to new knowledge, which is publishable in the peer-reviewed journals. While on the other hand, D.Eng, we have practical and applied research, which would be impacting engineering practice and technology development. Now, research approach for PhD is mainly hypothesis driven. You come up with a hypothesis and you prove or disprove to theories or hypotheses, while D.Eng is mainly the applied research, as I mentioned earlier. And aim here for PhD is to prove or disprove theories, while D.Eng, the main aim is to develop practical solutions, which will usually lead to innovation in processes, products, or technologies. All right, so with that in mind, let's just try to see if I can put a couple more things here. All right, so I think this, I should be able to move. All right, yep. So whenever you plan for D.Eng or PhD, whenever you go to some university, this admission process is quite different. You don't just say that, look, I'm interested in this program, here are my details. When should I start? What fees do I pay? Along with that usual admission process, you also need to provide the university with a research proposal. Now, why do the universities ask for the research proposal? Whether it's PhD or D.Eng, doesn't matter. Because this is the highest level qualification. As per Australian qualification framework, D.Eng or PhD, they both sit at the highest qualification level, that is level 10 here in Australia. So for that highest level of qualification, one needs to provide a research proposal. Why? Why do they ask for research proposal? So here are some of the points I have tried pasting here. So the first and the foremost reason is assessment of your research skills. Whenever someone says to the university that, look, I want to do some research, university needs to assess the research skills. So this research proposal actually allows the admission committee to evaluate applicants' research skills, including their ability to formulate research questions, design a proper research plan, and propose appropriate methodologies. Second reason here is alignment with department expertise. So each and every different department in the university has their own different research focuses, and they also would like to see if your research proposal aligns with the research interest and expertise and focus areas of that department for that potential research. The third reason is feasibility of research. So the research proposal actually helps admission committee to assess the feasibility of proposed research project within the resources available at university or institute. Now, this also includes evaluating whether the research can be completed within the expected time frame and whether the necessary facilities and supports will be available during that entire time frame. And then the next reason is identification of suitable supervisors. As you all know, D.Eng or PhD, we need supervisors to support us throughout the research journey. So well-crafted research proposal can also help identify potential supervisors who have expertise in that applicant's area of interest, and research interests, when they align, then supervisors are more willing to take those students as their supervised students. Last but not the least is the selection process. So research proposal is also used as key criteria in the selection process for the research candidate. Now, it will also allow the admission committee to distinguish between the applicants and select the ones who have the capability for conducting original and impactful research. So this is just to set the ground, just to explain you the importance of research proposal and why universities and institutes usually look for that. Now moving on, what is the starting point of the research proposal? Whenever you think about research, you need to have some sort of research problem in mind, right? If you don't have any research problems, then perhaps you don't want to do any research. There is no need for that. So what is a research problem and what should we look for? Now, a problem exists when there is a difference between actual situation and the desired situation. When they don't align, when there is a gap, then perhaps we can do, when we say that, oh, we can do a bit better, we can make this more efficient. That's when we can see there is a problem. And once the problem exists, our half work is done. So how to choose the problem? Now choose the latest topic, and please keep in the mind that it should have shelf life of 10 years. This is a little bit tricky in this era of innovation and artificial intelligence, where the technologies are advancing in leaps and bounds, but we have to be careful and we have to select something which has a longer shelf life. Shouldn't be something like you just start working on and then people have groundbreaking technologies already solving that problem. Now, it should also have some, if not huge, some monetary benefit to the company or society. Next is defining the problem. Now, when it comes to defining the problem, one needs to use the SMART principle. I will talk about that in the next slide, but yes, there has to be some thinking process going behind when it comes to defining the problem. What is the problem? How exactly you will put it into the words, whether the outcome is measurable, whether it's time bound. Those sort of things would make it SMART. And finally, once you have identified your problem correctly, you can formulate your research question. So what specific problem will be addressed? Now, how we would measure the success in solving that problem? What sort of resources would we need? So when we try to answer those sort of questions, that would formulate our overall research proposal. All right, so coming to the SMART principle, SMART is an acronym made up of these 5 letters. S stands for specific. So it should be specific, clearly defined, and focused. That's how our research question or research problem should be. It should also be measurable. So quantifiable criteria. There should be some criteria to measure the success. When would you say that the problem is solved? Okay, when I have devised this, this, and this, or when I have proposed this, this, and this, then we can say it's solved. So it should be measurable. Next is it should be action oriented. So there should be practical steps to address the problem. There has to be some sort of action, and then it should be realistic as well, achievable within the given constraints. We don't want to bring some non-existent material from Mars or some other solar system, right, to solve the problem. So it should be achievable within the existing constraints and time constraint. It shouldn't be an ongoing thing. It shouldn't take 15, 20, 25 years. I don't know how long, right? It should be time constrained. It needs to complete within that given time frame. So there has to be a deadline, right? So that's about SMART principle. Coming to literature review. Now, once you have identified your research problem, next step is your literature review. Literature review is super important. It really plays a crucial role in your research proposal. And why so? We have a few reasoning already here on the screen. So the first thing that makes research literature review very crucial is familiarization with existing knowledge. So when you formulate your research problem, you also want to familiarize yourself with what is already existing. So the knowledge of that existing body of knowledge is really important. So the literature review will allow researchers to immerse themselves into that familiarization. Now, when you review the relevant studies, articles, scholarly works, book chapters, you gain a deeper understanding of that field. Secondly, avoid repetition. So through literature review, we can identify what is already done in the field. We don't want to reinvent the field. So reinvent the wheel. So once we familiarize ourselves with what is happening, what is already done in the field, it will also give us a bit more idea about what is already done and what are the research gaps. So if this and this is already done, but this is my problem, half of it is solved, remaining half is not addressed yet. So that way we can figure out what are the research gaps. Now, once we have that idea, we can start investigating this further, and we can come up with proper, well-identified research questions. And last but not the least, building theoretical foundations. This is also important when we use the literature review. When we carry out the literature review, we also establish that theoretical framework for our further research and study. Now, literature review also provides insight into these existing theories, concepts, and that will also help us build that solid foundation for the research. Now, how would you carry out literature review, right? That's the next step. So I already told you why it's important, but how to do that? So you can start with some keywords. Say, for example, you are interested in smart manufacturing because that's also the area of my interest. So smart manufacturing could be one of the keywords, and then focus onto the area where you would want to apply. So smart manufacturing, and it could be the metal forming operations, or it could be the artificial intelligence. So just figure out your main keywords and try searching for those keywords. Now, for your papers, I would say initially start with the review papers, because review papers, they take into account lot of work which is already done in the past, and they review all that work. So they would give you a bigger picture idea. You will realize what is already done, what was really important, and what sort of outcomes have been derived through that review papers. Once you have selected your papers that you would like to go through, you would like to study more into the details, you can start reviewing those papers. This is the literature review stage. This is where actually you are looking into the papers. You're looking at the abstract, you're looking at the content, you're trying to see if that's important, if that's helpful, if it's relevant to your field, or you just discard that. Once that initial screening is done, you come to this critical analysis stage. So you go bit more into the deeper into the papers. You look at their methodologies, what sort of experimental setups they used, what sort of results they derived, and what are their final conclusions. So that would make your critical analysis stage. All right, so where would you start for your literature review? What are various different resources that we can use? Where can we find those journal articles, conference papers, book chapters? So here is a list. This is the one that I usually go to, that is Google Scholar, more like our usual Chrome, Google search engine, but this search engine is mainly focused onto the articles, research articles. Then databases like Science Direct, IEEE. You can also go to ResearchGate. That's a platform where researchers are there and they usually like to discuss what research they're doing currently. Academia.edu and CiteSeer. These are some of the resources, or some of the websites that you can visit, and you can start searching for the keywords. All right, be careful. You can use certain things and you cannot use certain things. So here, let's have a look at the types of acceptable publications, what we should be looking at. So pretty much you can see I've used the traffic signal analogy here. The green ones are the ones which are good to go, which we can use. Amber ones, just be slightly cautious, and red ones are big no. So in terms of acceptable publications that we can take into account for our literature review and research proposal, we can look at the journal articles, conference papers of reputable conferences, not some dodgy ones. We can also look at the books, which are really good reference for theory and some background justification. At times, you will also need to refer to the standards. So testing standards by various professional bodies will be quite useful while proposing your experimental setup. Theses are also acceptable. So previous work or previously published thesis is something you can rely on while justifying your research. Now, patents, I have put them in amber. So patents, consider them with care. Some of them are super useful, very well defined, very well written. Some of them are not. So be careful with that. And lastly, it's Wikipedia, which is not acceptable. So Wikipedia cannot be considered, it's Wikipedia, which is not acceptable. So Wikipedia cannot be considered as a very authentic source of knowledge. And that's why we only rely on these resources. All right, so these are some freely acceptable resources that we can use. All right, important aspects to look at in a published article. So let's go a bit more into the detail. I've given you the overall picture of your literature review. Now, once you have selected and shortlisted some of the articles that you would like to dig deeper into, what would you do? So when you look or read an article, look for the relevance to the topic. Just don't forget your bigger picture. What is your topic? Some articles might be so interesting, but they might be quite far away from the relevance. All right, so please keep that in mind. Also look for what sort of theoretical framework they have used in those articles. Research methods are also interesting. Have a look at the research methods they are using or they have proposed. Results and conclusions, obviously, they are super important, whether they actually solve the problems, whether there's some major errors there, if they have given any research gaps or idea for future research, future scope, that is also important. What sort of citations and references they have used? Sometimes this will lead you to another paper or another article, and that might also prove quite helpful. And how that published article fits into body of knowledge. So again, coming back to the bigger picture, how it will fit into your bigger picture. So once you have read through that article, you can capture that information into that sort of tabular form. You can list the authors, what year it was published in, the title of the article, all those details of the article, objectives, what research design methodology they used, what data collection and analysis methods were there, major findings, limitations if they have reported any limitations, what's the relevance to your study, and you can put some notes, basic notes. Now, once you have captured the tabular information, please try to present that into the text form also. Write a few sentences in your own words. It's super important to paraphrase. So at this level, at your level 10 course, we expect you to be able to understand, analyze, critically analyze, and then mention that same information in your own words. So present that text into 3 or 4 sentences about that paper. So I've given you an example over here. Here are some of my tips. So all literature reviews, they should be written in past tense, 3 or more sentences per paper review. Now, it should also capture sufficient details so readers can find the papers, right? So citations should also capture all the details. All papers mentioned in the literature review should be listed in the reference list. We need to create a bibliography at the end, giving the full details of each and every research paper used. We can conclude the literature review by summarizing our main findings. So we can identify the strengths, weaknesses, and gaps. So once we have done this, it will give us a lot more clearer idea about our research problem. And then we can propose our research questions. So this particular step will lay the foundation for developing specific objectives to solve our research problem. So what exact the problem is and what exact steps are we going to use to solve that problem. That is done once your research literature review is completed. Here is a sample. I've used IEEE style. So this is how your bibliography will look like. It's coming from here. What you can use, I actually wanted to show you this, but I can see I'm running out of time. I don't want to take up Vishal's time, so I wouldn't do this demonstration, but just an indication that this is one of the freely available reference manager software, Zotero. There is Mendeley as well. That is also freely available. So you can download this reference manager software and it will help you insert your citations wherever you want, and it will also make a bibliography for you for your proposal. So that's it from my end. I will hand it over to Vishal to continue from here. And yeah, regarding questions, if you have any, feel free to start typing them into the chat box. All yours, Vishal.
Okay, thank you, Dr. Aarti. Am I audible?
Yes.
Okay, thank you. Thank you, Dr. Aarti, for explaining problem formulation and literature review quite elaborately. Now, once the objectives are clearly defined based upon the gaps from the literature review. Next step is to go for research design. And this is what we'll be looking at now. Now, if you see here, research gap, research design and methodology. These are two different things, but they are quite linked to each other. Research design. So what is so for sake of simplicity, I have created 4 research designs here, and for each research design, what should be the methodology that is indicated here. Now, if your research question uh, is you want to do some experimentation, then it is the research design would be experimental study. And for doing the experimental study, what you will be doing is the methodology would be you will identify variables in the process, do experimentation, get data, do uh, and do the analysis part on that data. This is what will happen when you are doing experimental study. Now, if your research design is survey based, your research question indicates that you should do research, you should do some kind of survey in order to find the in order to address your research question, then obviously it will be you'll be designing a questionnaire, and again, you'll be launching that questionnaire to the target audience, get the data, and perform analysis. This is what you will do when it is survey-based study. The third one is simulation studies. If research design is simulation studies, so for this, you will be creating computer models, run simulation, get data, and perform analysis. The fourth one is something which is mainly related to the original research. Uh, in our D.Eng program, we mainly focus on first 3 parts. So here it is everywhere we are contributing to the body of knowledge. Here the progress which we are making is incremental. So over the years, you can see this body of knowledge will grow, and maybe in 5 years or 10 years, so you get a lot of there is a uh, considerable progress that has happened to the body of knowledge. But here, everywhere it is incremental. So we are moving to the bigger thing in increments, small changes, small innovations at every step. Whereas in original research, so you are focusing mainly on something new, some breakthrough research. Okay, now so when it is a research design, the research design should also address a few more things. In research design, we should address basically the 3 things. The first thing is, let me grab pen. Yeah. So the first thing is what type of data we are collecting, and what is the method of data collection, and how we will be analyzing the data. So 3 things are, uh, in fact, there are 5 things which are important, but the most important ones are first 3. Design. So research design. So what type of data we have. So for example, if we are doing some study, so what type of data we get, it depends upon our type of study. So we can have qualitative data, quantitative data, or mixed methods. If somebody is working in the domain of social sciences, they will be focusing more on qualitative data. So as an engineer, practicing engineers will be focusing mainly on quantitative data. But some research survey-based studies, they can have a mixture of quantitative and qualitative data. Now, so how we are getting the data, how we are collecting the data? So we can perform, say, surveys, we can perform experimentation, and we can also do simulations in order to get the data. Now, once experimentation, and we can also do simulations in order to get the data. Now, once we have the data, we have to do analysis. Whatever data we have, we will be doing analysis at 2 levels. First thing is we will be doing either estimation or prediction, and second thing is we will be going for some kind of optimization. Okay, now for prediction and For estimation and prediction, we can use various methods, say statistical methods, analytical methods, mechanistic models, or even machine learning algorithms are used these days. Okay, so my research design should have a few more things. It should also highlight how research work could be validated and ensure that the results are reliable and replicable by some other researchers. So this is also an important part of my research design. But as I said in the beginning, research design and methodology, they are quite associated. They are closely associated with each other. Okay, now coming to the structure of the uh, proposal. So what what should be there in your proposal? So it should start from here. So you will be identifying the problem as explained by Dr. Aarti, and then based upon the problem, you will be establishing the research question. Then your proposal should have a little bit justification and introduction in the beginning, but mainly we are talking about we have identified the problem and then we have established the research question. Based upon that, we'll do a detailed literature review. And after this literature review has been done, from the literature review, we'll try to find out what are the gaps. And from there, we will be defining the objectives, the specific objectives of the research. Now, once the objectives are defined, so I also explained that research design is to be done, what type of research you plan to undertake, whether it is experimental or survey or simulation, and then based upon that, the methodology is to be established. If you see this one, this document is quite well knitted document. You start with the problem formulation, literature review, research design, objectives, and then finally coming up to research design and methodology. Now, this document should also have few more things. One is, so it should also have the time frame for your project and what facilities you require. The most important part is budget and savings. So from the management point of view or from your wherever you want to present your project, so you must clearly mention how much how much is the budget for your project and what will be the saving. So this way you'll be easily able to convince your superiors or the company to invest money in this project. Okay, now it's time to see a few examples. So here I have indicated just one example, and there are subsequently you'll see more. So, so what should be the research problem? So the aim could be condition monitoring of an electric motor. Now, if you are taking this as a problem, this is too generic, so it is not specific. So Dr. Aarti also pointed out that we should be defining the objective and we should use SMART principles. So if you see this problem, this is quite generic. This cannot be a research problem. It should be specific and it should be focused. So if you see here, from the generic statement, we are now moving to the focus statement. The focus statement is developing a low-cost IoT-based predictive maintenance system for early detection of faults in industrial electric motors. Now, this one is quite specific. Everything is mentioned there. The goal is to plan for predictive maintenance system. And for that, what we want to have, we should have a low cost solution, and we also want to make use of IoT based systems. So low cost plus IoT. For what? The goal is to have a predictive system. And what is the application? We are applying it to electric motors. But still, if you see electric motors, we can use electric motors in different domains. So we should make it a bit more specific by adding, so where we will be using this electric motor. So application part should also be mentioned. So, and that is what is done in the final thing. Here in the last statement, it is now completely specified. Everything is given here, including where we'll be using electric motors. You can see we can use electric motors in assembly lines, pumping stations, food processing, pharmaceutical. So you can pick any one of them, one of the application, depending upon the industry in which you are working. So your problem, the end result is the problem should be very clear, specific, and everything should come into it. So this is how you should be defining your problem. Now, once the problem is defined, next step is to formulate the research question. Uh, so you can see here, this is again, I have tried to, based upon the based upon the problem definition. So a research question is formulated. Now, based after this research question is formulated, you will go to the literature review. Literature review, you will try to see how you address this question in the literature review, and from the literature review, you locate what are the where all researchers have consensus, where they disagree, and from there you locate the gaps, and then you formulate the objectives. So the objectives which you see here, this is outcome of the literature review. Now, if you see here, the objectives, so there are four objectives I'm mentioning here on this slide, and each objective is addressing some particular domain. So for example, so here we are talking about condition monitoring of electric motors. In here, if you see the first objective is to identify key performance indicators for electric motors. So it is electric motor, I can sense the condition of electric motor with the help of vibrations. I can sense it. I can come to know the condition of the motor if temperature goes up or if it is drawing more current or voltage. So there could be maybe 10 different ways by which I can come to voltage. So there could be maybe 10 different ways by which I can come to know what is the condition of the electric motor. So from here, the first objective is I will identify few out of 10, maybe I will take three indicators which are from where I can come to know the condition of electric motor. So this is the first objective. Now in the second objective, to develop uh, advanced diagnostic tool. So here, so this one is related to say sensors. So what type of sensor I will use, what size type of sensor I will use, what the interface cards, DA or ADC cards, what sort of sampling it should have, and whether I need to do signal processing, how to filter out noise from there. So all that comes under the second objective. So this one is related to sensor selection and data acquisition. The third one is the baseline. I have to establish a baseline. The meaning of baseline is, see, the ultimately I want to predict what is the condition, what I will be developing a model, and using that model I will predict the condition of the motor. So baseline means, so when everything is good, so when motor is good, so what signals I get. For example, this is for temperature. So this is the temperature range when motor is perfectly all right. So that is the baseline. And in the fourth objective, I will be establishing predictive models. So for establishing predictive models, I can use statistical method, I can use machine learning algorithms. So many things could be done there. So my model, the model will give me some prediction, and I should be able to compare the predicted results with the actual results or the baseline results. Then only I can say the my model is behaving as per the requirement or not. So the performance of the results that I get from my model can be compared with the baseline results. Okay, so now you see there are four objectives here, and on the next slide you see there are five more. In total, there are 9 objectives. So fifth objective is to evaluate the now I want to establish the maintenance strategies. So this one is related to mechanical engineering. And the sixth one is related to ergonomic design. The seventh one is related to cost benefit analysis, and here management is more interested in such kind of study. Then in the eighth one, it is related to manpower development, and the ninth one is to assess the environmental impact reduction. So obviously, when you see there are 1 to 9 are the objectives, so these are too many objectives. Any study will never have so many objectives. Maximum you can have say 4 to 5 objectives uh, to address. And how you select out of these 9, which 4 or 5 objectives I pick, that is a question which is quite important to answer. So how you pick out of 9, how you pick only 3 or 4? The answer to this is you should see what is in your research question, and based upon what is your research question, you will be picking only 3 to 4 objectives, not all 9. Okay, the point why I have kept all 9 is, so one problem, any problem can be addressed from different angles. So that is the reason why I have kept 9 objectives here. Now, another important thing is selection of 3 to 4 objectives depends upon what is there in your research question, and sometimes there is also a constraint, and that constraint is if the first constraint is the knowledge and skill that you have, that is first constraint, and second constraint is the equipment and setup, the access to equipment and setup, that is the second constraint, and time, which is also quite important. So your knowledge and skill is first constraint, and second constraint is access to the equipment that you'll be using for research, and time is also a constraint. But ultimately, what is given in your research question, based upon that, you'll be selecting, say, 3 to 4 objectives from here. Okay, now, so assuming that I have now picked only 4 objectives, the first 4 objectives that are shown. Now, how I address those 4 objectives, for that, here I will be mentioning now what will be the research design and what is the methodology. So for each of the 4 objectives, there is so one methodology. So first objective, I'll try to address first objective by following this method. And here what we are doing literature review, and we are consulting the experts in order to find out what are the key performance indicators which will tell me the condition of the motor. Second objective is here. So here I'm selecting various types of sensors. In the third objective, sorry, this is the methodology. The third objective from here will be addressed here in the methodology. Here we are talking about setting a baseline, and then the final thing, the final objective, the fourth objective, is addressed here in this methodology. So we will be creating prediction models. So this is how. So once the objectives are mentioned, objectives are established, and for each objective, how that objective will be met, that is what is mentioned here in methodology part. We call it research design and methodology. Okay, now the timeline should also be mentioned clearly, and so any project would have a, a fixed timeline. So here you can see the research methodology. So there were, say, 4 steps. So these 4 steps are indicated here, and when each step should start and when it should finish, that is mentioned here in the form of a Gantt chart. So this is a task data should be entered there. Uh, okay. Now the next important thing is the budget for what is the budget? Let me grab pen. Yeah. So what is the budget? Timeline we have established by putting everything on the Gantt chart, and now what is the budget? Now, if you see here, what I have done here for different tasks, So I have put everything, different tasks are here, and for each task, how much it is contributing in the budget section. Here it is task, how much it is contributing in the budget section. Here it is indicated in percentage wise, but you can put actual values if you have the values for the money that will be involved for each section. But you should put it here. It is given only in percentage terms, but it is recommended that you should use exact monetary values here. So if possible, you should also show how much will be invested and how much is the return. So management is always interested in knowing how much they need to invest and how much will be the return and how much time they will get the return. So if you are able to present everything there in this manner, then it is always easy to convince the company and your superiors to invest in your project. Okay, now a few more examples. Here, if you see, what I have done is I have created different titles, and for each title, there are few topics given underneath. So each title is related to a different domain. For example, so we want to work in the domain of condition monitoring. The first title is high voltage insulation monitoring with the unmanned aerial vehicle thermal imaging. So this is condition monitoring applied, but now it is in electrical domain. So condition monitoring we can also apply in another domain. It is predictive maintenance in manufacturing, but here I'm making use of machine learning. So the focus is machine learning. So we can say it is a part related to industrial automation. And the third one is rotating machinery condition monitoring using acoustic emission. So we can categorize it in a mechanical format. And the final one, so we are applying condition monitoring for knowing the condition of the bridge. So this is related to civil engineering. The same thing I have done for the other titles as well. If you see, the title is material testing. If somebody is interested in working in the domain of material testing, still you can select a different application. The first application is related to electrical engineering. The second one is related to industrial automation. The third one is related to mechanical, and the fourth one is related to civil engineering. So next title is so parametric studies. So this is a huge domain which can be explored in, again, we can see how this can be applied in different domains. Uh, you can see this one, effect of process parameters of the mechanical property, effect of process parameters on the mechanical properties of 3D printed part. So here, so we are trying to analyze how the process parameters are affecting the quality of a part. So in this study, so based upon that, finally what we'll be doing, we'll be performing either some estimation, or we'll be also going for optimization. So we can link this parametric studies with the estimation and optimization, but by and large the effect, what we are looking for in this study is we are trying to analyze, we are trying to see the effect of process parameters on the quality of the product. You can see the second one. This is quite interesting, which can be applied in the domain of industrial automation. Impact of different control strategies on product quality in high precision manufacturing. So different control strategies, those who work in the domain of automation, they know we can apply PID, we can apply these separately, and we can also apply fuzzy logic control strategies. So we can make a comparison there. So you can do such kind of studies, and the parametric study could also be applied in civil engineering, where we create a concrete which is having different constituents, and then we try to measure the performance or the durability of the part, the concrete block that we get from the study. Optimization and estimation and optimization. As I said, we can club process parameters with the parametric studies with the estimation and optimization, but we can also deal this topic independently. And here you can see the type of studies could be optimizing energy storage in wind farms for uh, supply demand balance. This could be one topic. And we if again, if we are still focusing on wind turbines, this topic, the third one, is machine learning optimization of wind turbine maintenance schedule. So here we are focusing on maintenance schedule, so it is related to mechanical engineering. And the fourth one, again, wind turbines, but now we are focusing our attention on the foundation design, so it will fall in the civil engineering domain. Sustainability analysis. This is again, now there is a push from various governments. So there is a lot of pressure on companies from the government side to develop eco-friendly solutions, products or processes or solutions. And there, if somebody is interested in working in that domain, this is a huge domain which can be explored. And the titles could be, again, if we can see the second title. So this one is, we can compare if we are manufacturing a part using 3D printing, and versus we are comparing a part which is manufactured by, say, die casting. So out of these two technologies, out of these two, which one is more eco-friendly? So we can perform LCA analysis, life cycle assessment analysis, and there are plenty of tools, freewares available for performing such kind of studies. Uh, Here, so again, the first one is related to electrical engineering. Second one could be, say, automation, and the third one could be related to mechanical. So like that, sustainability can also address. So when you're working in sustainability, you can apply it in different domains depending upon your problem and knowledge and skill that you have. Okay, the last one here, uh, which as engineer we least prefer, but still it is in industry it is being used uh, quite considerably. So survey studies. So in survey studies, basically you will be defining what you do. You form a questionnaire and you send that questionnaire to the target audience, get the responses, and then get the data and perform the analysis on data. What kind of studies could be done? If you see the first topic, survey data. What kind of studies could be done? If you see the first topic, survey on the integrate survey on the integrating challenges of solar photovoltaic systems into existing electrical grids. Now, this is a problem which is related to electrical engineering. The second, you see, industrial robot adoption, a survey on small medium enterprise. So what are the implementation strategies and what are the obstacles? So this could be related to industrial automation. Now, material selection in aerospace engineering, a survey on the use of composites. So here we want to see how the composites are used in aerospace industry for weight reduction. Now this becomes a mechanical study. And furthermore, the last one is sustainable construction practices. And if we do a survey on this, so this will be a civil engineering problem. So like that, depending upon what you intend to do, you can always formulate a problem based upon your research question, your competence that you have, and the resources to which you have the access. Okay, now, so that's all and from my side, but I would like to end this with this session with this beautiful quote. Fuel your curiosity with unexplored questions. Your research can lead to groundbreaking discoveries, and all the best for your research work. Thank
Thank you so
and if you,
much, Dr.
yeah,
Vishal.
yeah. So I'm open for any question or comment you have.
All right, everyone, if you have any questions for Dr. Arti and Dr. Vishal, please go ahead and drop them in the chat box, and we would be more than happy to answer your questions. All right. If we will just be waiting for your questions for a few more minutes, and while we are at that, I think Dr. Vishal is now about to tell us more about the Doctor of Engineering conference.
Yes, thank you, Lisa. Uh, so here we have a Doctor of Engineering. So this program we have on campus and we run it in online mode also. Right now the applications are open for Doctor of Engineering online mode. So the upcoming intake, the deadline is 22nd of July. The program duration is 36 months and delivery mode is online. We also take students for on-campus Doctor of Engineering program. We call it D.Eng program. And the for on-campus, the intake is 29th July. Again, the duration is same, 36 months. And we take students on campus. We are having two campus at the moment, Melbourne campus from where I am at, and my colleague Dr. Aarti is from Perth campus. So at both the campus, we are open to have students for this course. Another important thing which I would like to bring to your notice is that on 16th and 17th of April, we are organizing fourth Doctor of Engineering conference. This is online, so I encourage you to participate in this conference. So in this conference, there will be five expert talks. So these expert talks will be talking in their domain. They're from different countries, and we also have two workshop sessions followed by the presentations from our D-Eng students. So overall, this will be a quite nice experience, a lot of learning and a lot of deliberations over 2 days. So I would encourage you, and you can also, if some of your colleagues or friends wants to participate here, please you can share this link with them also so that they are able to register and they are able to connect with us. Thank you. Uh, Liza, that's it from my side.
Thank you so much, Dr. Vishal. I think we have a question here from Sirad, and he is asking if it is possible to assist him in formulating his research topic in the field of industrial automation, or IA, and it's specifically in RO desalination process.
Okay. To answer this question is we have uh, we have expertise here available with us. My colleagues are there. We specifically deal in four different domains: electrical, industrial automation, mechanical, and civil engineering. That's why in every problem you see, every problem for each topic, I have tried to give four topics. Definitely, we can help you in formulating the problem. There is no issues, but then you need to connect with us. So you can simply write to us, and whatever initial ideas you have in your mind, you can put it in your email. We can definitely help you modify it, refine it, and finally we will take it to a level where it becomes a research problem. Definitely, it can be done. I hope I have answered the question.
Thank you for that, Dr. Vishal. And that is the only question that we have as of now. And again, we would like to thank everyone for being able to attend and finish the entire webinar. And I would like to also let you know that to view our course schedule, you can go to our website or you can scan this QR code as well. And of course, if you'd like to book a call with one of our course advisors, you can also use that QR code to be able to be directed to that particular site where you can book the call. And we'll give you like a few seconds to be able to scan the QR code. If you need that, please note that there are no certificates for this course because this is only an information course. This is not a technical type of webinar, a webinar rather, not a course. So this is not a technical type of webinar. This is an information webinar. That's why we don't have a certificate for this one. And if you need to know more about our Doctor of Engineering course, you can go ahead and send an email to Dr. Arti here. She sent an email for you to contact them, especially CREG, who asked the question, and also for everyone in here. Okay. All right, let's proceed to the next slide. And for those who would like to attend our upcoming webinars, you can go ahead and have a look at our website. In our events page, we have our fourth Doctor of Engineering conference this coming 16th and 17th of April, and all other upcoming technical webinars this month, like a webinar for battery energy storage on the 18th, insights into EIT's postgrad programs and HVAC efficiency. We also have introduction to process control. All of them will be our upcoming webinars, and we are giving them out for free as well. The recording will be sent to your email directly within the next 2 business days. Please check your inbox by then and your junk folder as well. And in the beginning of this session, I have sent you the link to the conference, the Doctor of Engineering conference, and I can see that Dr. Arti had also, she also sent it now. So please go ahead and access that link for you to be able to join and register for our Doctor of Engineering conference. And if you do need to contact EIT, whatever reason may be, you can go ahead and log on to our website. We have a chat support in there. That's www.eit.edu.au. And if you'd like to visit our physical office, that would be at 1031 Wellington Street in West Perth. We also have phone numbers in here for both calling from outside of Australia and from inside Australia. We also have our emails here for webinar related questions or concerns. You can send an email to webinars@eit.edu.au. And for those who'd like to see our list of courses, you can go to our website. Just make sure that you go to the course schedule part or follow this link in here. And that's it for today. Thank you so much, everyone, for attending. And thank you so much to our lecturers, Dr. Arti and Dr. Vishal, for that compelling presentation. And I'm sure that everyone in here had learned a lot. Thank you so much for your full participation, everyone. Have a great day.
Thank you very much, Lisa, and thank you very much, everyone.
Thank you, Lisa. Thank you, Dr. Arti.
Thanks, everyone.